And today I will be discussing to you what is semiconductor manufacturing. We know that semiconductors are really important today because they are used in almost every piece of technology we rely on. And now, let us first define what is semiconductor manufacturing. So, what is semiconductor manufacturing? Semiconductor manufacturing is defined as the technologies used for the production of semiconductor devices, including integrated circuits and microchips, involving resources intensive processes such as photolithography, etching, and thermal oxidation. And now let's define also what is semiconductor. So semiconductor is also known as the digital backbone. So the modern world depends on semiconductors. They make digital functionality possible in a worldwide range of industries. From cars to phones, as how dependent we are on computing, communications, and automation, technology grows, so does their functions. These days, chips are essential to every significant business. They facilitate the operation of smart gadgets, provide worldwide connectivity, and stimulate innovation. Semiconductors, the building blocks of contemporary electronics, continue to create new possibilities in almost every facet of life. So the purpose is to act as the middle ground between conductors and insulators, giving engineers the ability to design devices in a way that drives modern technology. And it also provides the essential building blocks for modern technology. In this presentation, we will explore the three key aspects of semiconductor, which are the raw materials used, the process flow of wafer fabrication, and assembly and packaging of chips. Let us first begin with raw material. The most important raw material is silicon. Silicon is extracted from quartz sands and refined ultra-pure monocrystalline wafer. Serves as a substrate where circuits are built. Next is photoresist. Light-sensitive polymers used in photolithography allows precise circuit patterning when exposed to ultraviolet light. Next is dopant. Elements such as boron, phosphorus, arsenic introduced into silicon to control conductivity. Next is metal. Copper, aluminum, tungsten used for wiring, interconnects, and contacts to carry electrical signals. Electric. Silicon dioxide, silicon nitride provide insulation between layers and prevent short circuit. And lastly, we have specialty gases and chemicals. Oxygen, nitrogen, hydrogen, fluorine-based gases used for oxidation, etching, cleaning, and deposition. Acid like hydrofluoric acid is solvent for wafer cleaning. And now let's proceed with the process flow of semiconductor. So the first process is wafer preparation. The first step is preparing the wafer. We start with pure silicon, which is made into a large ingots and then sliced into thin wafers. These wafers are polished until they are super smooth because the defects here will affect the whole chips later. The second process is oxidation. Next, we grow a thin layer of silicon dioxide on the water. These layers acts like insulation and protection. It is important because it helps control how electricity flows in the chips. Photolithography. This is where actual circuit patterns are made. We coat the wafer with a pro-resist shine UV light through a mask and then develop it so it's only a certain part remains. It's kind of like printing the blueprint of a chip onto the wafer. The fourth one is etching. After photolithography, we remove the unwanted material. Etching can be done with chemicals or plasma. This step carves out the shape we need for the transistor and other structure. The fifth one is doping. To make the silicon conduct electricity in different ways, we add impurities called dopants. This creates p-type and n-type region, which are essential for transistor to work. Metal wiring. Semiconductors refers to the metallization process where metals like copper and aluminum form ultra-thin conductive pathway that connects transistor and other components inside a chip. This interconnection acts like the nervous system of the devices, enabling high-speed communication and power delivery. EDS process. The EDS process in semiconductor usually refers to electrical die sorting, a critical wafer level test step that identifies defective dies before packaging. It ensures only functional chips move forward, improving yield and reducing costs. And lastly, the packaging process. The semiconductor packaging process is the final stage of chip manufacturing, where the delicate silicon dies is enclosed in a protective package that provides electrical connection, mechanical support, and thermal management. It transforms a dies into a usable components ready for integration into electronic devices. And now let's proceed to the assembly for semiconductor. So the first one is wafer dicing. After fabrication, a semiconductor wafer is split into individual dies or chips, a process known as wafer dicing because it divides thousands of tiny circuits on a single wafer into usable pieces for packing. It is a crucial stage in the production of semiconductors. Next is die attach. The semiconductor packaging process is known as die attach. It involves attaching a single chip onto a backing plate, lead frame, or package base. It serves as package's foundation, guaranteeing the chip's operational mechanical stability and thermal conduction. Wire bonding. One of the most commonly used methods for electrical attaching a semiconductor dies to its substrate or package lead is wire bonding. Ensuring that power and signals can move between the chip and external environment is a crucial part of packaging process. The fourth one is encapsulation. The process of enclosing the dies, wires, and substrate with a protective material is known as encapsulation. In semiconductor packaging, it is functions as the chips armor, protecting it from contamination, moisture, and mechanical stress, while maintaining long-term dependability. Testing is the phase where chips are assessed to make sure they satisfy quality, performance, and reliability requirements before being sold. It is the last line of defense that keeps customers from getting faulty products. And lastly, we have marking and inspection. Before chips are sent, the last stages of semiconductor are marking and inspection. They guarantee that every gadget is correctly identified and satisfy quality requirements. So now we're done with the three key aspects of semiconductor. So we are here in the conclusion. Only one aspect of semiconductor manufacturing. Another is incorporating efficiency, innovation, and dependability onto each step of the process. Devices that power energy system, computers, communication, and lots of other applications around the world can be made because of this method. Semiconductor manufacturing will continue to be the foundation of development in the digital era as technology moves forward, smaller nodes, 3D integration, and sustainable materials. That ends my presentation. Thank you and good day.